In this tutorial, we're going to look at further possibilities for score layout. The points that will be covered here are bar line types, clefs and clef changes, how to write scores in C or not, and how to generate parts. First of all, bar lines. Of course, there are several bar line types that we might want to include in a score. The default in Slippery Chicken, though, is to have all bar lines to be single, even at section changes, but with the last measure to have a final double bar. These can be changed if you like using the post-generation editing method, change bar line type. This will, however, only affect the score. If you include repeat bars, these are not yet reflected in MIDI or CLM playback. So there are 6 bar line types which we can pass to the change bar line type method, and they're indicated by number IDs. So 0 is a normal bar line, 1 is a double bar line, 2 is a final double bar line, so with the thicker bar line included, 3 is a begin repeat, 4 is a begin and end repeat, and 5 is an end repeat. And you can see an example now on your screen using a couple of these different types of bar lines. So we're calling change bar line type after we've generated the Slippery Chicken object, and we're going to change in the first bar the bar line type to be a double bar, and in the third bar we're going to change it to an end repeat. The clefs that an instrument uses are defined in the instrument palette, which is loaded automatically at startup or provided by you when you create your Slippery Chicken object. So which clef is then used in the score is determined automatically by a Slippery Chicken algorithm. Write LP Data for All and CMN Display add clef changes by default. So if you are happy with the clef changes provided by those methods, you can just forget all about it and accept what they give you. However, if you're not happy with the clef changes provided automatically, you should set the auto clefs keyword argument to those methods to nil. This will not, however, affect the starting clef. You would then have to use auto clefs as a post-generation editing method. This is exactly the same method that's called by CMN Display and Write LP Data for All, but you can call it explicitly if you like. So we would call it explicitly with the SC object as the first and only argument, and then perhaps add or delete clefs by calling the add clef or delete clef methods of Slippery Chicken. Then we would generate the scores, setting auto clefs to nil so that we don't overwrite those changes we've just made. So in this example, we've got a very simple piece for solo cello, which could be using the bass, tenor, or treble clefs. We generate our piece normally and then explicitly call auto clefs. After that, we add a couple of clefs, for instance, in bar 2 before the second event, and this counts rests also, bear that in mind. We add a tenor clef there. Then in bar 3 before event 3, we add a treble clef, and we immediately delete that clef so that you can see that the method works when you look at the score. Slippery Chicken by default produces scores at reading pitch, so not in C. This could be disabled, i.e. you could create an in C score by setting the in C keyword argument to Write LP Data for All or CMN Display to T. So you can see in this simple example, which includes a transposing instrument, the B-flat clarinet, that when we call the CMN Display and the Write LP Data for All methods with the in C argument set to T, we get a C score. Slippery Chicken can generate parts for you, and in fact, all parts are generated automatically by LilyPond when you call the Write LP Data for All method. In this case, the file names for the parts will be the name of the player with the -part suffix added to it. And these will be automatically transposed for transposing instruments regardless of whether the score is in C or not. In CMN, we would have to explicitly call the CMN display method with each of the individual players passed to the player's argument. This would produce separate scores, one per player. And you can see this in our example now on the screen.